Today I'm going to talk about mainly two topics and they're to do with similarity. But in order to understand similarity, we first of all need to know what congruent is. So, two shapes are congruent if they are the exact same shape. So they have to be the same size and shape. So if they are congruent, they are the same size and shape, whereas if they are similar, they are the same shape, but they can be in different proportions. So they can have a side length which is like twice as long for every single side, and so on and so forth. So the main distinction is that if they're congruent, it's the exact same shape, and you'll be asked to prove how, and we'll look at that in a future video. If they are similar, they are the same shape, but they have some proportion linking them. And that's what we're going to look at mainly in today's session. So, the first scenario that we get is just looking at this one in the top left here. If these two shapes are similar, find x. Now, what we see is that we have line lengths, and we have two of them for one triangle and one of them for the other. And I want to find out what the missing one is. So, as it's just lines, I'm going to be looking at a linear scale factor. And in order to work that out, I need to think, what have I multiplied my 15 by to get to 18? So what we do is we just simply work out what is 18, because that's what I finished with, divided by 15, which is what I started with. Simplifying that down, that gives us 6 over 5, which is 1.2. So if I had any side length in triangle A and multiplied it by 1.2, it would give me the corresponding side length in triangle B. So therefore, looking at x, that would be equal to the side length in A, which is 10, multiplied by 1.2. So x must be equal to 12. That's really useful because that's just a linear scale factor, so it goes from centimetres to centimetres, so there's nothing we need to do there. They do make it a little bit harder, however, by if we look at, say, this shape here, it's not entirely obvious where my two triangles are. I've got some shape, and it's got a line through the middle, and they're parallel lines. We're told in the question that these are similar, so therefore we know that there must be two triangles, and if we think about it, there is this triangle at the top, which we're given some information about, and there's this overarching triangle over everything. So the easiest way to look at this is if we just draw out the two separate triangles. So this triangle here is ACA, so ECA, sorry, and this second triangle is just this top one, which is DCB. Once I've got that, I'm going to put on any information I know. So I know E to C, well this is 6 and this is 4, so altogether it is 10. And then my bottom length is 7.5. I don't know anything about C to A, so I'm just going to leave that blank for now. And looking at my smaller triangle, I know that D to C is 4, and D to B is what I want to work out, so I'm going to call that X. So again, I'm looking at linear scale factor because it is a side length, and I'm going to think, how do I get from 4, which is my smaller triangle, to 10? So I do 10 divided by 4, which would give me 2.5, and that would be my scale factor. So therefore, E to A, which is 7.5, because I'm working backwards, I'm going to have to divide this by 2.5 to give me what x is. 7.5 divided by 2.5 is 3, so therefore my x value is 3. So, if I'm going from a smaller to a larger one, I have to multiply in this scenario. If I'm going from the larger to the smaller, I would then need to divide. Okay, what I'd like you to have a go at is first of all have a go at this triangle here, tell me what x is, and if you need help, I'm going to show you the two triangles as well. So, looking at this, I'm going to put on my information. I know that my base lengths are 8 and 5 respectively. I know that this length here is x, and I know that this length here must be 2 plus x. Now, to work out the relationship here, again, it's linear scale factor. So that's going to be my value of 8 divided by 5, which is equal to 1.6. And the reason that this is a little bit trickier is because we have two values of x now. I want to find out what my smaller value of x is, and I know the relationship is x multiplied by 1.6 is going to be x plus 2. So x multiplied by 1.6 is going to be equal to x plus 2. We know how to solve these types of equations. We subtract x across, so we have 1.6x, take away x, equals 2. Well, 1.6x, take away x is going to be 0.6x. If that is equal to 2, what I can do is divide both sides by 0.6. So therefore, x is going to be equal to, well, 0.6 is 3/5. It's going to be 10 over 3. And I would just leave it as a fraction. That's about as hard as they come for linear scale factor, but what we're going to move on to is we're going to be looking at how we can use a linear relationship to tell me more about different relationships of triangles or any shape. So, here we can see I've got two shapes and it says they are trapeziums and they are mathematically similar. So that means they are the same shape, however their proportions are different. And I'm told the area of one of the shapes is 36 centimetres. Work out the area of a shaded region. So, I'm looking at this. I know the area of one of them, but I don't know any other relationship. So what I have to do is I have to think back to what I just looked at, which was my linear scale factor. And for this scenario, I've got a side length of 18 and 12. So 18 over 12 is equal to 1.5. If I think about the units, that's going to help me massively with looking at area. Well, these units are centimetres, and my area scale factor, well, area is in centimetres squared. So what do you think I have to do to my linear scale factor, which is in centimetres, to get to my area? Well, it would just be 1.5 squared, which is 2.25. And likewise, just going to show you now, if I have a volume scale factor, well, volume is measured in centimetres cubed, I would have to do 1.5 cubed. So, let's look at the question at hand. Work out the area of a shaded region. Well, if a smaller region has an area of 36 centimetres, the larger region, so A, B, C, D, area is going to be equal to, well, it's my 36 centimetres squared, multiplied by my scale factor, which is 2.25. When I work this out, 36 multiplied by 2.25, it's going to give me 81. And that would be the area of my large shaded region. So putting this all together, I have two shapes. They are mathematically similar, and I'm told that the surface area of a solid A is 20 centimetres. What is the surface area of solid B? So, putting everything together, I know I've got a linear scale factor, an area scale factor, and a volume scale factor. The linear is in centimetres, this is centimetres squared, and centimetres cubed. Again, I need to look at the shapes and see what I have for both of them. They both contain a volume, so therefore what I'm going to do is take 640 and divide it by 10 to give me that volume scale factor. That is 64. Now I'm struggling because I don't know what my linear or area is, and if I'm looking at surface area, I need to find out what this is. So, if something cubed is equal to 64, my linear scale factor is going to be the cube root of 64, which is 4. And I can then go from my linear scale factor to my area scale factor by squaring it. So I get 16. So if I wanted a linear thing, I would multiply by 4 from a smaller shape. If I wanted the area, I'd multiply by 16 and so on. So in this scenario, the surface area of A is 20. So therefore the surface area of B is going to be equal to 20 multiplied by 16, which is going to be equal to 320. And this would be in centimetres squared. That brings the end to the video. What I'd like you to do now is, if you have any questions, please let me know.